Hello everyone, welcome to this lecture. In the previous lecture, I have talked about the fundamental of combinational circuits and sequential circuits. In this lecture, I'm going to talk about the half adder. So half adder is one of the combinational circuits. That means it doesn't have any memory element. So there are few things. Half adder is capable to add only 1-bit information. So there are two 1-bit number half adder can add. So remember few things. Can add two 1-bit numbers. Second thing, it cannot handle carry. Right? So let's say you have two numbers and the previous carry is coming out. It does not deal with it. So it cannot deal with previous carry. You can say it cannot handle previous carry. So I write previous here to avoid confusion. So it does not handle the previous carry. Any previously generated carry it doesn't have. So now let's draw. Let's say I assume this is the half adder I am drawing. So let's say there is a circuit which is representing half adder. It is taking input. So I'm just considering two inputs, and it is generating, let's say, two output. So it generates two output like as sum, and it also generates carry. And there are two inputs, so you can take any input like A, B or X, Y, whatever you want to take here. So let's say I'm taking two input like A and B here, and both of these are only single bit, right? So this is a half adder. Okay, now how does it work? So let's draw a truth table of half adder. In half adder, the truth table look like this. Where we are having, let's say, input A, input B, we are also having sum and carry, right? So sum and carry will be decided by inputs. So two input can have four combinations: 0 0, 1 1. A can have, and this will like 0 1 0 1. So these are the four possible combinations, and we are aware about when we add 0 0, there are two bits and both are 0, sum we will get 0, and there will not be any carry out, right? But in case we are having 0 1, in that case the sum of 0 1 will be 1, and there will not be any carry, so carry will be 0. Similarly, if we have input as 1 and 0, the sum will become 1, but there will not be any carry. But in case we are having 1 1, we know that in binary when we add 1 and 1, two numbers, then the sum will become 0, and we will get 1 carry as output, right? So I hope this truth table is not very difficult to understand. You can easily understand this truth table. All right. So if we draw the circuit for the sum and carry, first write the Boolean expression. So let's say the Boolean expression of S we can write wherever S is 1. So there are two places when we are getting sum as high. And this value we are getting when A is 0 and B is 1. So that means we can say the S is when we are getting A bar B. A is 0, B is 1, and there is another case when we are getting sum as 1 when A is 1 and B is 0. So we can say either it is A is 1 and B is B bar. So this is the Boolean expression of sum, which we can also write as, this is the Boolean expression of XOR. So we can write A XOR B, right? Now if we write the Boolean expression for carry, the carry is only one place we are getting where the carry is giving us output as 1, and that is AB, right? So in that case we can write carry as AB, because this is the only place where we are getting carry. So if we want to draw the circuit of half adder, this XOR, so let's say we draw the circuit. So there is an XOR which is taking two input like this, and this XOR, it is generating. So this, let's say this is A input and this is B input. In that case we are getting this is as sum. So this is the sum. Now what is carry? Carry we will get in terms of, we apply one AND gate. So let's say this is an AND gate, and the input we can take, let's say we are taking this input as B, and this B we are connecting. There's another input we are taking as A. A is coming from here, and we are connecting like this, right? So here we are getting carry. This is the diagram for half adder, right? So I'm ending this lecture. In next lecture we'll be talking about full adder. Thank you.